Hi guys, how are you? I hope all you are doing good. Welcome to the Learn Code Easily. So today we will solve this medium level question, that is count good nodes in a binary tree. And here it is given that we have a binary tree and we have a node x. Node x is called a good if the path from the root to x, if there is no element in the path that is greater than x. What it means, here it is given 3 1 3 4 1 5. As you can see in this path, when you go from 3 to 4, so 4 is the x, because 4 from root to x, so x could be any point, x could be any point in the path. So 4 is greater than 3, so this is 1. Again for 5, 5 is greater than 4 and 3, so this is the second one. Now 3 is again our node, so this is also the good node. And here 3 1, so 1 cannot be, because 1 is not greater than the other node from the root. But if you come at 3, then 3 is greater than 1, 3 is also greater than or equals to 3. So that is all about the question. Here the answer is 4. I hope you understood. In this question, why it is only 3? Because 3 is the one node, that is good node. Now again you will come at 3, then 3 is equals to 3, that is also good node. When you come at 4, 4 is greater than all of the other node from the root, then it is also a good node. Now let's solve it. So we need to take a variable, that is the count good node. So let's take as 0, and here I'm making one of the function, that is finding good node, so that is root. And here what I need at every point I need to capture the max value. Now I need to call this function, that is root. What the max value? I'm passing the minus infinity. So you can pass also any of the means the value which is not in the node. So here it is going from 1 to 10 to the power minus 5. You can also take minus 1 as well. What you need to return? You need to return simply self dot count of good node. So here if root is null, you need to simply return, else you need to call the left and right child of it. What you need to call? You need to call the left, then you need to call the right. And also you have to find the max value at every point between the root value and the max value. You need to do the same thing for the when you're calling for the right child. So as you are moving to the right, as you're calling for the left, you have to find the max value, so that you can get the maximum value in the left side, and you can also get the maximum value in the right side. Now you have to increment the count of good node. So what you can do here is, if root value means the root dot val, if it is greater than or equals to max of this one, then you need to simply increase the count variable, that is count of good node. So that is all about the question. So what I'm doing here is, I'm calling 3, then I'm calling the 1, then I'm calling again 3. So when I'm calling of left, then it is null. Now I will come at 3. So what is root of at this point? When I have called the left, it is null. Now I will come at this point. So what it is saying? It is saying root of val. Root of val is 3, that is greater than or equals to root of val. So I need to find the max value between the max val and the root val. So at every point I was passing the max value. So I have got the 3. So 3 is greater than 3. Yes. So I am incrementing my count of 1. When I again come back to 1, then I will again call. Now here the root of val is 1. That is greater than the 3 value. No, so we cannot increment. I will call the right, it is null. So I will again go for 3. So the left has been called. When I will move to the right, then I have to go through from this point again. So root of L is 3, that is greater than equals to 3. Yes, that will increment the count. So in the same manner I will do for the right side of it. Let's try to run it. What it is saying, a bad operand type of unit. Let's see what happening here is count of good max value max root of L, that is max, then root of L, that is greater than root of L comma max value self dot count, that is also correct. Okay, I have written wrong here, so we need to pass the minus infinity properly here. So this has been done. Let's uh, apply some more. Let's try some more test cases here. So all has been done. Let's try to submit it. So it has been submitted. I hope you have understood, guys. Here we are just traversing the tree. So that's all from my side. I will meet in the next video with the next video. Till then, bye.